take them downing, take them downing, take them down. As you look, the whole room explodes. Take them downing, take them downing, take them. As you look, the whole room explodes.
Daniel Chen from Taboola.
Good evening almost. I know it's late, I'll try to make it short. What I'm gonna tell you today is a short story about Taboola migration from MySQL to the world of NoSQL. So I'll talk about the leap from MySQL to NoSQL, as I said. I'm the operations director at Taboola. I'm responsible for the production IT. Taboola does content recommendation, as you can see here. We recommend videos, we recommend other content as articles across many publishers in the world. One example is Bloomberg. This week we also signed a big contract with Yahoo Japan. We'll do the content discovery and recommendations for them. Okay, so Taboola is the largest content discovery and recommendation network that exists today after Google. But Google doesn't do video recommendations and articles recommendations. They do sales recommendations, ads, or things like that. We serve around 150 billion recommendations per month. We have 150 employees across the globe, 5 data centers. The 6th one is being planned and built as we speak because of the big deal with Yahoo Japan this week. We are Cassandra users since the version 0.7. That's almost 3 years from now. We use Apache Spark on top of Cassandra for analytics. And we are now testing Google BigQuery for analytics purpose on huge amounts of raw data. So I'm going to talk about why staying with MySQL, why migrating away from MySQL. Just a second. Why migrating to Cassandra specifically and DataStax's enterprise version that we use, overcoming NoSQL limitations, our use cases, obstacles, and finally I'm going to talk about BI solutions for big data. So why staying with MySQL? It's a good database platform. Okay, most of us startups use MySQL on a day-to-day basis. And everyone is used to SQL. It has its own advantages for small-scale solutions. And I'm talking about even 5 terabyte is considered small-scale solution, 5 terabyte database. If you need the ability to insert data from different locations, then MySQL can't do that. And that was our main reason for migrating. I'll talk about it here. The architectural limitations of MySQL can't allow you to do bidirectional replication. You can't insert a user event from one side and send it to the backend, and from the backend send the recommendation based on that event to the other side. So we had the data model limitations, we had scalability and performance limitations by MySQL. The master-slave architecture, as I said, just didn't work. We had to find another solution, and we chose to move to Cassandra. Why Cassandra? Because it's massively scalable. you can just add nodes and your growth is linear, even for writes, even for reads. We get no single point of failures. If one server fails, the other one doesn't, it's not affecting other servers. We have a flexible dynamic schema. We can add columns, drop columns. We don't have these problems like MySQL cluster. There's a big community developing, but at the beginning it was very difficult. When we started 3 years ago almost, there was a very small community, especially in Israel. So when we decided to go on production with Cassandra, we chose to use DataStax Enterprise. And the reason for that is that it provides you 24/7 support by good solution architects. One of them is Johnny that was lecturing this morning. We have good integration with Spark, Solar, and Hadoop. In the next coming version, DataStax Enterprise will support Apache Spark coupled together. There is a new feature that we use that's called in-memory tables. And we have a fully featured Ops Center to manage and monitor the entire cluster. Our cluster, by the way, has almost 80 nodes. So at the beginning and even today, things are still not perfect in the Cassandra world. We had many problems with counters, so we dropped it and built something of our own. vNodes had problems with the gossip, if some of you use Cassandra and know about it. And level compaction had many bugs until recent versions. So things were not straightforward and a bit rough at the beginning, but now things are becoming very stable, and we like it. We had some problems with the drivers mix-up. We tried Hector at the beginning, and then AstyNX, and finally we are planning to move to DataStax native driver, which is the recommended one. And we had also problems with consistency, but they were solved after we did different model for our data. Of course, there was a problem of NoSQL and the joins. We wanted to do some analytics on our data, and what we did is use Spark on top of Cassandra. So Cassandra is being used as our data store. Spark is running RDDs on the Cassandra data store, and using Shark, we can run fast queries on top of Cassandra data. In the near future, Spark will provide something called Spark SQL, which will eventually replace Shark and will become faster and better. So our first use case was the recommendations. Each recommendation that I've showed you in the beginning was replicated from our backend generator to the front-end data centers, and from there was served through Akamai to the end user. MySQL was not scalable enough. The single-threaded MySQL replication couldn't handle so much traffic, and so we had to find a solution, and Cassandra was very suitable for that. We had an issue with the user events. We wanted to store, if some user clicked X on one of our recommendations because it was offensive, we wanted to have a bidirectional replication. We wanted to let the backend know that the content was offensive, and we had to replicate it from the front-end data centers to the backend data center. You can't do it in MySQL, but you can do it in Cassandra. And of course, the Spark that is being used for many tools. The special tool of them is an online tool for the publishers to find the best headline for an article that they recommend on. We can do an online A/B testing for headlines with Spark and Shark on top of the Cassandra data. And the support, at the beginning the support was a bit weak from DataStax. Today is very good, and I can recommend them. Obstacles. So first, we had to figure out the concept. All of us were used to the RDBMS world, and moving to the NoSQL world was a bit mind-changing thing. There was a problem with the maturity of the NoSQL world. I reminded that we joined this world 3 years ago. We had to choose between the driver mess and do the correct topology. We figured out that even using Cassandra with spinning disks didn't help. We had to use SSDs, so our entire cluster is based on SSDs, and Cassandra loves SSDs. If you think about deploying a cluster, please use SSDs. We had some problem with inconsistencies and problems with the repairs. The repairs used to get stuck. We figured out that recently, actually, upgrading to recent kernels, 3.14, helped resolve many repairs problems that get stuck. But even though these are all obstacles, the Cassandra works well, and we are very happy with that. Some BI tools. We use several big data solutions. One of them is Spark, as I said. One of them is the Cassandra, and even BigQuery. If you want to do BI on all of them, what I suggest you to use is use the Simba driver. Simba driver exposes ODBC that works with almost every BI tool, and it gives you the ability to connect to BigQuery, to Cassandra, to MongoDB, and many others, and lets you see the big picture in one place. So that's it. It was short. Any questions? Yes.
A bit far, sorry. First question, did you move all your data to Cassandra, or just some parts of the data and leave the other ones in MySQL?
The configuration we kept in MySQL, and the raw data and the recommendations and the metadata we moved to Cassandra. So we have 90% of the data in Cassandra.
Okay, so most of the data, it's about the algorithms you run. So that's the data you...
It's 90% reads and 10% writes, if you want the ratios. That was the question?
Yeah.
Okay.
Thanks.
Any other?
Why BigQuery?
Why BigQuery? Mm-hmm. So the problem is that we store around half a terabyte of data per day, of raw data per day, and we didn't want to keep JBODs of data on our place. So we figured out it would be better to send them to Google Cloud Storage, and then load it from there to BigQuery and analyze data across years of data, actually. So it's faster, we don't have to maintain many JBODs in our place, and it's cheap. Today it's cheap. It used to be very expensive, but today it's cheap. Okay, any other questions? Okay,
No
thank
more
you very
questions.
much.
Daniel, thank